everyone, this is a video about mathematical induction. So mathematical induction is a proving way in which where you analyze now a series if that is true for the next term. So let's go now and have this problem. So prove by mathematical induction 1 squared plus 2 squared plus 3 squared continuing to n squared is equal to n times n plus 1 times n plus times 2n plus 1 all over 6. Now, let's have that. There are 3 steps. However, some others say there are only 2 steps. However, in my case, I really want to do it in a 3 steps so that there will be a specification. What are we doing? The first step is to evaluate. Okay, evaluate n is equal to 1. So, for example, if we have now 1 squared, that will be equal to the sum, which is this 1. So, you have now 1 times 1 plus 1 times 2n times 1 plus 1 all over 6. So, this would be on the set, this would be 1. So, having that, let's fix that it's 1 times 2 times 2 times 1 plus 3, that will be 3 over 6. So, therefore, we have now 6 over 6, or technically that would be 1 is equal to 1. So that's now the first step. However, when I was in college, what we did is that we also checked the second and the third. So if that would be true. So let me just give you an example. If we are now looking now on the second, let's see if n is equal to 2. So therefore, we have now 1 squared plus 2 squared. Is that equal to 2 times 2 plus 1 times 2 times 2 plus 1, and then we have now all over 6. So what we have there is 1 plus 4, that will be equal to 2 times 3, then 2 times 2, that will be 4 plus 1, that will be 5. So we have now 60 over 6 rather, then we have now 5. 2 times 3, that will be 6 times 5, that will be 30 over 6, and therefore that will be 5 is equal to 5. So rest assured that you are correct, even though you're going to work out with other on the set of the natural numbers. So now let's go into step 2, which is substitute n by k. So therefore, in the equation, let me just have it 1 squared plus 2 squared plus 3 squared plus plus that would be turning out to k. Everything will be turning now to k. So we are now working with k plus 1, and then we have now 2k plus 1 all over 6. And then on the third step, let me just have another page. Okay, I have now. So on the third page, we prove now if it's true, prove if k plus 1 is true. When they say now k plus 1 is true, remember that we have now 1 squared plus 2 squared plus 3 squared, then the ellipsis, which means continuous, and then we have now k. And then let's look at now that this now would be k plus 1. And then now we're now proving now, remember that we substitute now, it will change now our sum. So everything would be added 1. So we looking now on our example, look at that on the screen. We're going to put now plus 1 on every k on the summation. So we call that a summation because it gives us the sum of all the terms in the series. So we have now k plus 1. And then we have now on inside would be k plus 1 times 2 times k plus 1 all over 6. Now, we could say that this part, let me just have this on a different color. So as you can see that this part is known to be k plus 1, then 2k plus 1 all over 6. It's like this one. So we can have that. And now when we prove that, we are now using this one, and this. So let's simplify that now and let's have some proving. So when we prove, let me just get the pen now. So what do we have there is k times k plus 1 times 2k plus 1 all over 6, and then plus k plus 1 is equal to, let me just simplify that. So we have now k plus 1, then we have now, there's 1 here, we have now k plus 2, and then we do have now 2k, 2 times 1, that's 2, plus 1, that will be plus 3 all over 6. Now let's solve this. Make sure that the left hand side and the right hand side would be equal so that we could prove that k plus 1 is true. So first thing to do this is to make it a linear where there's no denominator. We will not use the fraction. So in order to have that, what you need to work on is to multiply both sides by 6. Okay, when we multiply that by 6, let me just make it clear here on this side. So what we do have left there, if we multiply both sides by 6, so we have there k, then k plus 1, then multiply that to 2k plus 1, and then plus 6. Oh, this should be squared rather. I have a mistake here. It should be squared. Remember on the equation, I forgot, they will be on the squared. So that will be k plus 1 squared. I apologize. So that will be squared. Make sense? So this would be k plus 1 squared. And this would be equal to k plus 1 times k plus 2, and then 2k plus 3. Does it make sense now? Okay. So at this point, we can now cancel what are the terms that are the same on both sides. So as you can see, let's analyze that. Let me just give you an analysis on it. There are k plus 1 here and k plus 1. So you can cancel now k plus 1. Cancel here. So there's a remaining of k plus 1 here. And then this will be gone. So what is left? We can now write what is left there. So what's left there is k, then 2k plus 1. Plus 6 times k plus 1 is equal to k plus 2 times 2k plus 3. Now, I think we can now simplify this one. So k times 2k, that will be 2k squared plus k. Then we have now 6k plus 6 is equal to k plus 2, k times 2k, that will be 2k squared. K times 3, that will be 3k. So you can see the process. 2 times 2k, that will be 4k. And then 2 times 3, that will be 6. Now, as you can see, when we simplify that, we have now 2k squared plus 7k plus 6 is equal to 2k squared plus 7k plus 6. And if you can see that if the two sides are equal, therefore we can now conclude that k plus 1 is true. Or in the induction, that it is true on the next term. I hope you learned something with this one. Thank you very much for watching.